Welcome everybody. We're going to be able to factor polynomials specifically with the AC method. And how can we do that? Because we're going to convert it into a quadratic. X squared plus AX squared plus BX plus C. We're going to make this. And if we can do this, then we can do the AC. What are we missing? The ACB method. So here we go. So I have x to the fourth minus 7x squared minus 44. Now, what I can do is I could pretend to do a few things. Hold up. So I'm going to make this into a quadratic by saying, hey, I'm going to let d equals x squared. So then this x to the fourth would be d squared minus 7d minus 44 is equal to 0. Now if I plug this back in, d is x squared, that's right here, and x squared times x squared is x to the fourth. So this is still true right here. So now what I'm going to do is I'm going to take this and I'm going to understand 1 times negative 44 is negative 44, and I want negative 7. All right, well, let's do it. How can we figure this out? Okay, well, what times what equals negative 44, and what plus what equals negative 7? Think about it. All right, well, I'm going to guess it's going to be 11 and 4, because 11 times 4 is negative 44. But I have negatives. So if I make one of these negative, and I add them together, I still have a negative. The bigger number should be negative. So I should have the following. I should have d minus 11 and d plus 4. Now, just to make sure, I can do the following. I'm going to plug in d squared. I'm going to plug in negative 44. And now what I can do is I could plug in d minus 11 and negative 11d and positive 4d. And if I simplify these, I should get the same answers right here, which is true. So if I go further, I can now substitute. So remember, d was equal to x squared. I can bring it back. And so now I have x squared plus 4 times x squared minus 11 is equal to 0. So my two answers for this, well, there's more than two answers, but I need to have this equal negative 4. Well, the square root, so I'm going to have to find the square root, because it's going to be what squared equals negative 4. Can't happen. So I'd probably have 2i right here. Let's show you. So I want, basically, remember I is the square root. Well, negative 1 is equal to I, because it's going to be an imaginary number. So basically, I'm solving for this. I say, hey, x squared is equal to x squared plus 4 is equal to 0. Minus 4 is equal to x squared. That's where I got this right here. Do it in my head. I'm like, all right, I'm going to have the square root of x squared is equal to negative square root of negative 4. And at that point, we should know, hey, this is not going to give us a real answer. So the answer is going to be 2i. I'm going to go positive or negative on that as well. But let's leave it like that. In this next one, I should have x squared Add 11 to both sides is equal to 11, and this one should be the square root of 11. So I should have, let's throw it in. I should have these as my answers right here. These are my solutions right here. Not so nice, but we still got them. All right, let's try one more before you guys have some independent work. So we're gonna try to solve this. We have 3x to the fourth minus 22x squared minus 45. So at the moment, I'm going to try to get this so that it's x squared and x. So once again, what I can do is I know that x squared squared will equal x to the fourth. So I can say, hey, let a equal x squared. So I'm going to have 3a squared minus 22a minus 45 is equal to 0. So now at this point, I have my quadratic, and I know I can multiply 3 times 45. 3 times 5 is 15. 3 times 40 is 120. So I should have negative 135 for 3 times 45. Oh, negative 45. Then I'm going to have negative 22. All right. Well, looking at this at the moment, I'm going to start going through this. I'm like, all right. So I could do fives. I mean, I see 135. I mean, I know I'm going to have, like if I do 10, that'd be 13.5 times 10. So if I half this and make it 5, then I'm going to be timesing it by 27. And that's going to give me a number close if I add or subtract. So this should be negative 27, and this should be positive 5 right there. So this is not 1 right here. So I'm going to have to do our box, our area model. So I know my top left and my bottom right are going to be the exact same. So I should have 3a squared. I should have minus 45. Now this should be negative 27a, and this right here should be plus 5a. So looking at this, it looks like this will be 5 right here. And this should be 9. But not 9, negative 9, because 5 times negative 9 equals 45, negative 45. This should be a, and this should be 3a, using our factors. Now let's test it. 3a times negative 9, yep, we're good. So, rolling this out, I should have 3a plus 5 is equal, times, a minus 9 is equal to 0. Cool. So we know that the answers will be 9 and negative 5 thirds. But wait. Remember we said let a equals x squared? We're going to bring them back. So if we bring them back, we should have 3 times x squared plus 5, and we should have x squared minus 9. So if I was to solve for each of these, I'll solve 3x squared plus 5 is equal to 0, and I'm going to solve for x squared minus 9 is equal to 0. So I'm solving for, hey, this is a factor and this is a factor. So then if I get this, I'm going to slowly get x by himself. And if I do that, I'm going to get a few answers. So for this one, I'm going to get an imaginary number because it has a negative inside the square root. For this one, I think I'm going to get a nice number. So if I find the square root of x squared and the square root of 9, I should get x is equal to positive and negative 3. So if I was going to write out the answers, I would say, hey, x is equal to positive or negative 3. And I would say x is equal to positive and negative 5/3 I. If I was going to take it out, I'd probably want to. So just so that we know that, hey, look, we have two real answers and two imaginary answers. All right, guys, sorry this one was a little bit long, but I'll catch you in class.